Okay, thank you everyone. We're ready. Jakub is, as I said earlier, he's the linker guy. He loves giving talks about all the nastiest internals of file formats, the weirdest, wrongest thing that all OSs love to do all over the place.
That's not true.
But I asked him for today only to look at the bright side and talk about YAML instead. Please give it up for Jakub.
Thank you. Thank you. It's not true, by the way. And this is the first talk I'm giving actually that's related to a linker as well. Right, OK, so let's go with it. So this is not a talk about parsers, but, well, let's talk about parsers, right? Because it's YAML. So first thing, like, let's parse it. And this is actually very important. So a linker author, that's me. That's actually what I go by on GitHub and everything else. So if you see this, that's me. A YAML parser is like Zig YAML. We're going to get to it. And then what's in Zig? Have you guys seen Ziggy? Yeah. Fun fact, I actually got them confused. I thought that 0 was Ziggy and Ziggy was 0. And then since then, my daughter says that I'm wrong. That's not Ziggy. And this is 0. So there we go. So we might want to change that. She's not going to back out. And then why? And this is the most important thing, is like why? And why YAML? How many of you actually know what YAML? Like seen YAML, worked with YAML? Excellent. Now, how many of you like YAML? You do? Wow, you should have done it then. Like you would have done a better job than me then. Because really, like why YAML? Like there is so many different formats, right? And YAML is really bad. Right, OK, before we go there, so a bit about me. For some of you who don't know me, I'm the linker author. Some stuff, I'm not going to go through it, but I started contributing in early 2020. I go by KubeCon everywhere, effectively. I'm a core team member. I'm proud to say I'm working full-time since, I don't know, I think April 2021, right about when, actually I'll get right about after what happened. Yeah, I like code-gen linking. Surprisingly, it turns out that I like reverse engineering like a lot. I don't know, it's like this satisfaction that you reverse something that people say like don't do it. It's like OK. So I wrote Mako linker from scratch, and actually it was off like it started off like as a dare with Andrew. He taunted me, like it's his fault, by the way. He did it. He said like as you can see there, like I dare you do it. We already by that time had some incremental linker for macOS for Intel. That was roundabout when I think M1 was just around the corner. It was I think when DTK were kind of announced. I got one and started playing with it. And he said like do it, because we couldn't get it to work with LD like at all. It just wouldn't work. And I said OK. So I don't know. Fast forward I think 2 months, and we could actually already link C. Zig, C. C++ was still not there yet, because C++ is actually a very complicated language, and the file, actually the object files it generates are really complex. Rust as well, by the way, although not as much. But we could do it, and I was like, I think 0.8, so that's like ages ago. We didn't even go that back. And some trivia about me: I said that I started working full time in April 2021. And I started saying like after something, and actually I'm known for quitting Microsoft. That's all I'm known for. So it's not about linkers. It's the fact that I quit Microsoft for 3 months because it was so bad. I was working on stuff that I didn't really like JavaScript. I was like, I don't do JavaScript. Why am I here? So since then, I've been writing parsers at Six Software Foundation effectively. Usually with bits and bytes, but sometimes occasional text like YAML comes on. I'm just getting started. If you guys want to talk about anything from like Dwarf to PDB, I'm your guy. I'm pulling my hair out with Microsoft right now, so I'm happy to talk about this more if you want to know about the insanely complicated stuff that Microsoft invented ages ago, God knows what for. So why YAML? How many of you guys actually are working on macOS? OK, cool. How many of you know what is happening between here and there? Because Loris mentioned about cross-compilation stuff, and he said that the easier one is, what did you say? was like from Mac OS to Linux.
Yeah.
Actually, no, it's not. I wouldn't say it's easier. How many of you know if you can actually invoke a syscall directly in assembly on Mac OS? Is it okay or not? Actually, it's okay. It's just that they tell you not to, but you shouldn't, right? Because they say like, well, it can break anyway at any time. We don't have hard-coded syscall numbers. We can change them. They never have.
It happened with Go, I believe. Like Go used to not go through the libc; it would do the direct call, and then at some point everything broke. I don't know what happened, but
I don't think they changed it. I remember speaking to an Apple engineer. He said he wants to. I was like, why? Why do you want to do that? Don't do it. But anyway, they say don't do it. You have to go through a dilib, right? A dilib is like a shared object on Linux. It's a DLL on Windows. Dynamic library. So basically what's happening there, you have actually two syscalls as far as I remember, write and exit, but we generate an extern function called to write. We pass in the pointers, the data, whatever. It then loads in the link system. Like basically you link in lib system, the loader loads it, and everything works. The OS is happy, everybody is happy because we go through their bootstrap routine and all this crap, and we put stuff on screen. And this is very important. Like this is the most important thing. So normally, that was like a couple of years back. You just, as a linker, you generate the object file. Compiler generates the object file. The linker takes the binary file for libsystem.dilib, looks for the symbol. Oh, it's there. Cool. We're gonna link it in. Easy. But things changed. They introduced a thing called TBD. Anybody knows what TBD stands for? Actually, that's actually good. Maybe that was it. Oh my God, that must have been it. Oh my, it's actually text-based definition, but maybe it was to be decided, and they're like, yeah, it's good enough.
Well, you know how in Monkey Island, Guybrush used to be called Guy.brush? Maybe that's the same story.
Wow. Wait, did Apple not take part in designing this game? I'm not sure. Anyway, yeah. So TBD, and do you know what TBD is? It's a YAML. Actually, no kidding. It's just a YAML. So nowadays, if you want to link with any system library, you gotta parse YAML. That's it. Right? I was like, okay. And this is sad news. I didn't want to write YAML parsers. Like, that was my only goal. Like, I just want to link this stuff. Actually, that was the motivation for the parser. It kind of blew up a bit. There was a guy, I can't remember, from Berlin, who actually used the parser to do some...
Adam Serafini.
Oh, right. Actually production processing stuff, I think, for their code. Yeah, and I was like, wow, okay. Wrapped it in Python, it was faster. I was like, okay, that was never the goal. Like, actually, I didn't even know how to write parsers then very well, so it's not even written with DoD, but it worked faster. I was like, okay, cool. It does quite a few allocations. It's a standard thing, but we'll get there. So I did it because there were no implementations in pure Zig, and we want to keep Zig dependency free in the sense that you download the 40 megabyte tarball and that's it. We don't want to ship more C libraries. We already ship LVM. That's quite a lot. So why libyaml? I mean, it's there, but So write our own. And since then, that's what I've been doing. Just writing everything, like write our own, PDB, write our own. This, write our own, linker, write our own. Everything is write our own. Maybe it's good. So the architecture is pretty straightforward. I don't think it's got anything like super complicated. The most interesting thing that we'll get to is, I think the fonts are kind of fucked here. It went like everything like, okay, whatever. It's okay. The things got squeezed a bit. I'm going to pretend I planned for it, but I didn't. So the architecture is pretty straightforward. The most interesting bit is actually the deserializer that we're going to get to. This is a thing where different languages will shine or kill the entire thing, depending on how you do it. So let's quickly go through it. I'll see much better here. So the first thing, I don't know how many of you guys actually have experience with parsers, compiler. See, everybody knows this. I can just skip it. You know what tokenization is, right? So this is very simple, except that it's YAML, so I still don't understand the spec. I think the spec doesn't like me. And by the way, if anybody comes up with like, if there is like a spec test suite or something, oh God, please just port it in, just start testing this. Because I just, honestly, my goal was just a linker. I didn't care about any other use case. And people start like, oh, this doesn't work. I was like, oh, yeah, I know. So, and I sometimes like, I think I take, yeah, well, it's not for me. I'm like, add it, feel free. I think I take like 2 weeks every year and I add some stuff, fix some bugs. But other than that, it's just, I don't actually maintain it very well, to be fair. So the tokenizer is very simple. A is a literal, then we have a colon and white space, actually one token. That's the map value in indicator, I think. That's what it stands for. Actually, literal should be, I think, scalar. I think that's what YAML calls it. Scalar. I was like, right, okay. Oh, peril. Interesting. I have a PhD in applied mathematics. When I see scalar, that doesn't mean that. So I was like, no way. This is what it looks like if we parse this. And this is actually valid YAML. I swear to God, everything is a valid YAML. Like I tried it, and there are like tools online, and I think they have a function that returns always success. Like everything always works. And I'm like, why? So what's the spec for? And like, so it's very simple, like literal map value and then literal, and then EOF as an end of file so that we know when to stop. Because otherwise, we don't want to loop forever. This looks a bit more complicated. That's the parser. This it's not very well written because the tree of nodes, every node is on the heap. Pretty slow, not very cache friendly at all. This could definitely be improved. Like we don't actually need to store anything on the heap. To be honest, like this, we can just have a contiguous array of nodes and just reference them by indices. But I actually learned that way later. So and rewrite. If anybody wants to rewrite this, feel free. And I'll gladly use it in Zig, like the compiler as well. So basically, when we parse this, we get we should get a map. A map in the trees in a parse tree here is represented as a list of nodes. Effectively, that's it. And then each key is basically a token index that you can then reference each edge. The interesting thing is because I didn't know how to do. Maybe I would do it differently nowadays. I don't actually check if there are duplicates right here. I should do it later. So if you have duplicate keys, it's going to be flagged up in the next stage. But the user is still going to get the error either way. Then we get to the decoder. We get a string hash map of values. A value is this. So this is like semi-typed. I'm saying semi because it's still a value. So you can actually have a list of values of different types. And then when we actually apply types to them on the output, then we should actually validate that they're actually the same type or not. Or promote or demote, whatever you want. Very simple. And then compound types list of like a slice of values, and then map is represented as a string hash map. And you should notice here that this is a string hash map. Again, this is super inefficient because every string has to be stored on the heap or a point. Like basically, pointer cannot move. If it moves, then everything goes to shit. So, so we actually have a very nice context adapter version of string hash map. If you guys want to have a look, it allows you to basically use indices as keys instead of actual pointers, and you can store strings in a string buffer.
Right.
Sorry, too difficult. Cookie points from Microsoft, they actually do it in PDB, which is actually a good idea. Okay, so this is the interesting thing, and I wanted to talk a bit more about. It's the so Loris started talking about the comp time duck typing, as he called it, like the introspection here. So this is actually this was the most fun to write. Like honestly, like parsing is boring, tokenizing even more so. But this was interesting. And in Zig, like basically writing a deserializer is super interesting in Zig because the comp line is the driver. It's not that you have a type, like in Rust you implement a trait. I think they implement a trait in Serde, I think, for deserialization and serialization. And then you have crazy proc macro that basically, you do the derive or something, and then it does it automatically. Like actually, I think someone asked about how we do comp time, and in Rust, as far as I remember, they actually do create a binary that's being run again by the compiler, which means you can actually do some serious damage on the computer. Like people actually were stealing bitcoins, as far as I remember, this way. because they would get like a trait, like a proc macro that they install some kind of malware on your computer. Not very good. So here, we actually, instead of implementing any traits, we do comp time introspection of types. So we check what the type is, and then depending on this, we get the value from the untyped map, and we try and stick it into the type that's there. If they don't match, then we flag an error. So how does it work? Oh, I have some code. Cool. No, I knew this. It's just a joke. So we have two like, let's focus on the struct, because that was the map thing that we saw earlier. So basically, we have the parse that recursively will call another version of parse that's specific. Like basically, it's specific to some kind of a type that we discover. And we have this built-in called type info. So for any type, the type info will give you everything that the Zig compiler sees about your type. Like, is it an int? Is it an enum? Is it a struct? Is it an optional? Is it a null? There is a type called null. It's very interesting. There's void as well. So all this stuff is being given by type info, and then depending on what it is, we can actually specialize the function and effectively generate different versions of the same function using the duck typing. And then, so basically for the struct, we would go into the struct and parse struct with value as map, because that's what we expect, right? If it's a structure, we expect that we have to deserialize that as basically from a map, because otherwise it wouldn't make any sense. Like a structure will be key to value. That would be typed as a structure, okay? And it's obviously, if you want a map, you can just leave it as it is, untyped, and then you can have all the accessors the standard way. Then we go into the parse struct, and this is somebody asked about inline for. I think it was you, Simon, right? So we do have inline for here. Like Simon doesn't like it. I use it a lot. You did say you didn't like it. No, I'm sorry. You said you didn't like inline for inside an inline for, which is just insane, but OK. So inline for is cool because for basically you get the struct info for the struct, and it gives you all the fields. So the fields that were declared in your struct, and then you basically iterate over them. So inline for is going to unroll into like all the if statements, and then if anything is a match, you just do an if. You basically parse the value out, and that's it. And then you return the parse value. And how many of you have actually programmed in Rust before, for example? Anybody tried it? How many of you actually know what Certa is doing underneath? Anybody wrote a proc macro before? OK, one person, cool. So you know what pain is, right? And you know what pain is to actually maintain this. Because you actually do like, you template the output code with like, I think 2 hashtag values or something. It's crazy. Like you actually define the variables, then they kind of like capture them into your template, and then you output that as your final code. That's what proc macro does underneath. I did it once. I was invoking the compiler with a different target to compile for a different target, to then take that binary and then launch it over the network. It worked, but maintaining that was hell. I like this one more because that's it. There's no proc macro. It's basically, there's only Zig code. It's just that you have to remember that some of it is invoked in comp time. Some is actually in runtime, and that's it. And actually works well. So quickly on the inline for here. So basically how everything works, we have this const t struct that expects one member A, which is a signed integer, 64-bit signed integer. That's what we're going to cast the original map to. So if you remember, it was like A colon space 12. That's what we're going to want out. And we do parse value, then it's a structure. So we actually don't care about what the parsed YAML was yet. We basically use what we expect to drive, like to compare, like, is it actually this? Can it fit into this? If it can, then we're good. So we go into parse value, that's a struct. We parse the structure, then we do inline for all fields in T. Yeah? And then obviously this is like a recursive thing. Then we call for each of the fields, parse value, that's an int. We return 12. We go back out, and we have T A of 12. There wasn't an error, so like everything actually matches. We're good. And this is also, I think, kind of important because it's kind of loose. I think when I first saw TypeScript, I don't know if you guys tried TypeScript, JavaScript. Oh, is it like unpopular topic? I'm sorry. Actually, JavaScript is not bad. So TypeScript, types, and they do a lot of like this. I was gonna say destructuring, but it's not. It's like you can. I think it's called structuring. I can't remember what it's called. Basically, you don't have to specify the type. You can just say like what structure you expect, and it's just gonna match it. This is kind of a similar thing, similar idea. You just do the struct. You don't care. You don't have to label the type. You just care what it's got inside. In this case, it's just a struct of, has a I64. We have some data. Try and match it. If we didn't, well, we expected something else to run error. And I think it's cool. And actually, you should do this. Like parsing, you can forget about, but try write something like this. It's awesome. Like honestly, when you get it working, you're like, oh yeah, that's how it works. Okay, so I like writing parsers, surprisingly. Writing a linker does require writing a parser. I thought it's only binary, but it's not. You get the YAML once in a while as well. Thankfully, I think for Microsoft call format, the stub files are simple lists of symbols, so that should be easier. No YAML. Although YAML can be versioned, and I think that's why Apple did it, which is okay. It's just that I wouldn't do YAML. And writing parsers in Zig is actually fun, and especially deserializers. So I encourage you to go and do it. Okay. So yeah, Loris already mentioned that. So if you like Zig, we would like to help out. Please consider donating. The more money we have, the more people we can actually hire to speed the process along, to get more features in. We have so many ideas, just not enough time. We will gladly take big corporations' money, but we will never give them a seat. It's like the motto, like, sure, give us money, but no influence. And yeah, that was me. So ask me anything. By the way, it doesn't have to be about this.
Okay, thank you.
Maybe not the front-end stuff. I'm not really good in front-end stuff.
You said, Jakub.
You're not allowed to ask questions.
No, this is just a correction. You said that Microsoft has no YAML. Microsoft has no YAML yet.
Oh, yeah.
We'll see.
I hope not. God, I hope not.
Okay. Any questions about YAML parsers or anything else?
Cough, PDB, health, no. Mako. Yeah.
How do you handle error reporting for degenerated code?
I haven't. Oh, you mean for YAML?
Yeah, for this or even the standard library JSON parser.
Oh, I didn't do the JSON parser. I don't remember how JSON. Actually, JSON parser is done in a nicer way because it's streaming. This is how this should have been done as well. To basically just instead of, because this one allocates too much, then it's true. Yeah, there is an issue for this. So basically, the error reporting is reduced to basically throwing like one error code, and that's it. As in like error, I don't know, like expected this, expected that. But there is no bubbling up of actually what it happened. So I haven't. There is an issue for it. If you want to, feel free.
This is not a sneaky way of advocating for errors with payloads, right?
Oh, no.
Okay.
No, definitely.
Oh yeah, not gonna do that. No, no allocations. So yeah, good question. I haven't done it, but feel free. There's an issue for it. Yes.
Do you handle those YAML pointers? Like
No. Don't kidding me. Why?
No, wait. What's a YAML pointer?
Oh, don't even. There's like even you can annotate object thing as well. You have like.
you can have a hash, right? That have a key.
Right.
The value can be hash. It doesn't have to be a new hash. It can be like an existing hash that you have already somewhere else in the tree.
What's
So
the
it can
syntax?
be like
What's the syntax?
I think it's a hash.
yeah, it's like a ampersand something.
Yeah.
And
Ampersand. Holy.
Yeah, there is ampersand. There is a exclamation mark for. You can actually add a type to YAML. I was like, okay.
Composers using that.
Sorry, yeah, I did.
people who like YAML for writing config files. Like,
They actually type them as well.
but
Wow.
the history of YAML is more like some crazy Perl person wanted to
Oh, that explains it.
serialize
Okay.
data, and like when you have this
Of course.
arbitrary data structure, you kind of need to be able to point to yourself. So
Right.
they added that, and it should look a bit like JSON.
A bit like JSON. It's nothing like JSON. Yes. Next question.
Yeah, maybe not exactly related. I
Mm-hmm.
And yeah, it was annoying. And after I'd done that, I realized that there are tools to convert from YAML to like JSON and all of things, which have already libraries, but maybe they don't map one to one or something. Did you ever consider?
Convert? No, because I don't. I don't want a tool, because if I need a tool, then that means I need to write this tool. And if I need to write a tool for converting, I might as well write a parser, because it's the same thing, right? It's like.
You were ready-made converter.
But I don't want to have any dependencies. We don't want to ship anything that's not, first of all, ours. It's like, for example, another example is, I don't know if you guys knew this, especially those who work on Mac OS, there is a thing called dsym. It's a debug symbols bundle. It means that instead of having debug symbols in object files scattered around, you can actually pull them into one binary that's got everything in it. The way Xcode does it is they call a tool called dsym-util. Awesome. I don't want to do it. Like, I want dsym-util part of the toolchain, so that if anything changes, we fix it, not wait for Apple to do it, at next WWDC, which may never happen. So that's the whole premise. Plus, we want to keep it like smaller as well.
That is also another annoying thing when it comes to Go cross-compilation, because cross-compiling Go from Linux to Mac, if you have a debug build with debug symbols, then Go will assume that
you have dsym-util in your path.
And you don't, or I don't know, the one from LLVM, the last time I tried wasn't okay, so I basically had to create a Go executable without the bug symbols, because otherwise Go would keep complaining over and over. Yeah.
But
It
was the first time I heard that idea, but I think it probably works. So if you build a streaming YAML to JSON.
Yeah, we could use the JSON. Yeah.
And you don't need to support pointers, because
We don't need to. Like, exactly. Apple doesn't even generate that stuff.
Could work for your
So
well,
yeah. No. Oh my God! If that happens, I quit. So the TBD, basically TBD is a product of a thing called Tappy. Tappy is a text API. I think that's what they call it at Apple. And it's not man-made. The YAML is always basically what they do. They say like this dialect, which actually does exist on macOS. It's just that it's not accessible by you or me. It's in a secret, hidden, read-only partition that only DYLD has access to. And it always computer generates that. So we're good. I don't think we have to expect pointers. Yes?
You just mentioned that you don't want to rely on Apple.
Yeah.
I've been in the same situation, relying on these TBD files and the definitions to be updated. And they release new Xcode 1 year, and the next year and a half, they actually release the source code. In the meantime, since you don't...
No, like 2 years, I think, but yeah.
Yeah, and in the meantime, I can't really rely on that.
Uh-huh.
How do you do it? Do you just reverse engineer
Yes.
and just rely on
Yeah, I find it like a lot of fun. I just sit down and go like, why? No, but I do that, yeah. For example, I did reverse a couple new features from Mako as well that, yeah, they weren't open source yet. But it's LLVM guys do the same thing.
Like the code signing stuff for a facility.
Yeah, but that was easy. That was the first thing. Then nowadays the linker does optimizations that match what the kernel is doing, and it's obviously not documented anywhere. So that's the only way forward.
Yeah, I mean, there's the TP1, TP2, TP3 version.
And 4, yeah.
Yeah, and they may.
Yeah, so we have a nice we have a notification system for this. People come over and say like, "Hey, broke," and there's like an error. Tap here. I was like, "Oh yeah, YAML, time to update." So then I'm like, "What version? Give it to me. I'm gonna have a look." And that's how it works. So YAML is easy because it's text-based. So just a couple of fixes here and there. The problem is with binaries.
Yeah.
Like the moment it.
1.5 years.
Yeah. So the oh my God, and they do it every release is something new. So yeah. It's fun. It is fun.
Any other question?
Yep.
The cross-compilation against Windows.
Oh, Windows, my favorite nowadays.
Which type of
GNU. I'll stop you right there.
libraries are you using there?
The MinGW for now. So now you mean like so MSVC is on a to-do list, but for MSVC. Before we actually get there, I need to advance the linker enough and understand enough about the stub files that Microsoft is using to be able to do it. The moment I do that, and surprisingly, so here's the thing, like it took me a long time to write the macro linker. It's still not feature complete. There are some things missing for C++, for example, no unwind info, but whatever. Then I started looking at COF, and they also use the same concepts like address, space, layout, random, ASLR. There is like everything has to be a PI. My favorite word is a PI, like position independent executable. It went like this. Like in a week, I had a running linker because the concepts are the same. It's just that the layout is different, for example. So the moment I learn how the stub files are generated, we don't actually need to ship the DLLs. We just need the stub files for kernel 32, for NTDLL, that's it. If I have the files that are, for example, versioned for a particular version of Windows, we just use them to cross-compile and we're done. And then at runtime, because I think they're always available, I think only the MSVCRT is not available. And I don't know, is that .lib or is that DL? I can't remember. That I will need to investigate, but everything else is there. So we didn't even have to worry about the user not having them. So if there are problems with this, I'll need to figure it out, but we'll get there.
I think we're good, maybe?
I have a
Yeah.
question. So I have a more on philosophy of SIG question.
Okay.
So if you have a function that takes any type, so today if you want to put constraints on that type, maybe only accept a type that has a function or something, you have to write inside the function, you have to write code that can
Correct.
a compiler error. Is there any, or what is the SIG thought about making something that is like a code time trait or like a contract where you can specify?
I'm gonna defer to Loris because he spent more time on this than me.
Yeah, for sure. This is obviously annoying, so I'll maybe re-explain for people who maybe missed part of the question. So one of the main ways in which Z can do generics is with the anytype keyword, which is it allows you to pass in any type, as the keyword says. Problem is usually you don't really want any type, you want some types, types that conform to a specific interface, not necessarily in the sense of runtime polymorphism, but in the sense of trait, in the sense of this thing has these methods, has these properties. But in Z, there is no concise way of expressing that, while in other languages there is. So what's up with that? I think there are 2 points here. One is that, yes, obviously it's annoying. I do not think that a trait system will make it into the language. I cannot make an authoritative claim because it's not up to me. The people, and even the people who it is up to, might not 100% know yet. So we have recurring design meetings where Andrew and a few other people discuss proposals. But the problem is, in my opinion, the reason why I suspect it's never going to be a thing probably is because the moment you give this tool to people, everybody will start pontificating on their code. Everybody will start doing C++ shit in Zig, to put it in, pardon my French. So I think that having some friction there is not bad from that perspective. Think of it in this way. Go. I like Go. I think it's an awful language in so many ways, but I still like it because I experienced it in an enterprise setting where people were going insane with C# metaprogramming of the worst kind. And Go, by virtue of making it hard enough to do some of that metaprogramming, actually provided some value. That's my personal take. One thing that we certainly should have at some point, at the very least, is a userland library that allows you to do, let's say, trait checking in a more straightforward, standardized way. Like some userland library where basically you say, okay, this struct needs to implement these 3 methods, needs to have this property, auto-generate standardized-ish error messages whenever you pass in a type that doesn't conform to that thing. I think we should totally have something like that. I think some people have already implemented some libraries like this, although there is not yet a blessed implementation that people want to use. It's complicated.
Yeah.
It's tough.
But on that topic, I wanted to show because you can basically just have you don't have to like write it out yourself in the sense that pollute your actual function implementation a lot. I'm looking for format, I think. By the way, fuck. Yeah, I'm sorry. Format is, by the way, a good resource when it comes to. Is that it? Yeah. Mixing comp time with runtime stuff. By the way, if you want to like learn how it's done in some way, we have a thing. Oh no, I'm not talking about format. Fuck. It was hash map, I think. There is like a function called verify context or something like this. That basically instead of like writing it out.
I do the same in OK Redis.
Oh, there we go. Cool, right? Just you write. Where is it? Is it? Oh, right, there we go. See verify context. It's purely comp time, and then that function is then called wherever you have context to verify. Instead of like doing all the type info in a kind of like a separate bit, you basically have it here as a separate function. That's it, right? Yeah. But yet the traits, I don't know. It's up to Andrew mainly, and I don't think he's going to go for it because it's too complicated.
When I mentioned earlier that comp time has its own trade-offs and downsides, I guess you could say that this is definitely one of the downsides of comp time. The problem is that traits are a dangerous tool. People, it's like moth to a flame. It's like, oh my god, I can now impose constraints. I can pontificate on how users should use my code. Let's go bonkers with it. And then you have factories like in the blink of an eye. I don't know.
So it depends. For like user-facing API, I guess the problem. But if you have internal stuff, you know what you're gonna have, right? And any type is actually sometimes really cool because you don't have to spell out everything. Just say any type, and then you know what to expect. Boom, works. So.
It really feels like I wrote some runtime deflection in Go.
Yeah.
And it feels exactly like that, except of course this is running at compilation time.
Exactly. Yeah.
This is exactly the same logic. And yeah. But do you have runtime reflection?
No.
No. Okay. I mean that makes sense.
You can create it.
Yeah, you have to write it out yourself.
Yeah, you can introduce it. I mean, technically, I think we do have a tiny little bit of runtime reflection. I don't know if it qualifies, but if you want to get technical, error names and enum names, this information is in the executable if you try to print their name. If you don't try to print their name is not in the executable. So it's tiny little bit of runtime information. Okay, any more questions? Otherwise, I think we're good. Okay.
Yeah.
Then I suggest we give our two guests and speakers a good applause for the talks.